Conservation is one of the areas that GIS really has a chance to come to the forefront. Adam Fox highlighted that in some of his examples this morning. And along with GIS being able to help with conservation, AI also has an opportunity as well. One of the groups that we work with, FLAP Canada, is a group focused on mitigating bird collisions with buildings so that we can better understand how our built environment can help with conservation. And one of the ways that they do that is through their global bird collision mapper, where they collect observations of birds from around the world to help us understand where we're seeing collisions and how we can mitigate them for building owners. With this example, this is all the data they've already collected. A lot of great stuff. But how could we use AI to help us even further with some areas of accessibility and image interpretation? That's what we're going to take a look at this morning. Here I have ArcGIS Survey 123. We're going to use the new Survey 123 Assistant to help us build a survey and then configure it a little bit further to do some analysis on the images and audio that we'll submit. So let's get started. Using a large language model, we're able to generate a survey using basic prompts that are well crafted. And that's the main thing. Every interaction with AI starts with a well-crafted idea, a well-crafted prompt. Here, I'm going to put in some text that I want the AI assistant to build me a survey that utilizes audio, video, mapping to bring together a few different questions that help me fill out my survey. Generating that survey, it's now going to provide me an interpretation of the different questions based on what I've asked. Here, I could then go back and forth in natural language and have a conversation with it to configure it further, but for now, I am happy and we're going to generate it. And in the span of a few seconds, it's going to create the entire survey for me, and AI is going to help us get about 90% of the way there. That's where we, as GIS professionals, come in with that last 10% to edit it further. And here, the survey's ready. Now let's do that last bit of configuration. It has a question here for us to submit an image, but I also have a description question where we could put in an answer ourselves or have AI analyze the image that we're going to submit later on. We do that by coming to our calculation field, choosing select a property, and we're going to choose that question where we're going to submit, and then analyze the image. And again, this is using a large language model where we're going to provide a prompt for it to do its analysis. Hitting continue, this is where I need to then provide it with a bit more information. So I've already crafted out, again, that well-crafted prompt for me to put in where I want it to describe what's in the photo, including some of the common markings that are found on the bird, various shapes, and go so far as maybe taking a guess at what kind of species are we looking at based on the context clues of Canadian birds. That's great, but let's continue on with a little bit more to help us with some accessibility of our survey. We have a question here where we can also provide an audio recording of my description of what am I seeing, because maybe text description isn't something that I'm the best at. So having an audio question, we can then do a further question to pull out that information like we do for our image by doing a calculate, choosing again our question, and this one we're going to choose that audio description and configure it again for that transcribe audio. Coming back down and grabbing another prompt, we're going to ask it to identify the language and just transcribe the provided text. No need to do anything extra to it yet. And now, in the next question, we're going to ask it to take whatever language I've then transcribed from the audio and take that into English. So again, instead of choosing our audio question, we're going to choose that language that it's transcribed and choose analyze text again with one last prompt to put in. And now I've done these in advance, but these are something that you can work on over time to craft it to give it the best chance of getting you your answer. With all this ready, we can hit publish, and I want it to go ahead. So in that few seconds, we've now started a survey, crafted it, and as it's publishing, we're now going to go over to our tablet where we can submit an actual entry into our survey. As it does its work, we're going to come into our iPad and pull it up, and hopefully by the time we get there, we're ready to go. And here we have our FLAP Canada survey. Here, we'll submit our image from our photo library of a bird that we've found. And now it's going to do that description for the audio. It's a small bird that's outside. We have some distinct yellow markings, and it could even be a magnolia warbler. I've done that check beforehand, can confirm it's right, but we always appreciate a second chance to look at it again if we need to. And this is where we're now going to do an audio description of what did I see. J'avais vu un petit oiseau noir avec des jaunes à la poitrine et à les épaulettes. Il est mort après il a frappé mon fenêtre. And just like that, now that I've stopped the audio, it's going to work on doing that translation. And then we see below that we have it in English. And just like that, we're able to use Survey 123 to help us with various stages of our observation work when it comes to conservation. But that's at the local level. We then also need to think, how does conservation look at the global level? And that's where our next case study comes in with our beluga whales. This is a project that Mohamed has worked on alongside the Department of Fisheries and Oceans, where they're understanding whales in the Arctic to see what is the health of the Arctic and the impacts of climate change. This is an episode of a podcast that we did together where he dives into it further, but let's see what's happening behind the scenes. Thank you.
Thank you, Michelle. So imagine if spotting whales in the vast Arctic seas could be as quick as brewing your morning coffee. Sounds amazing, right? Let's turn this imagination into reality using the power of GeoAI and ArcGIS and transforming pixels into powerful insights for ocean conservation. With ArcGIS, you can manage the entire deep learning workflow from accessing your imagery, do your data labeling, training your model, and doing your inference at scale. And the best part, the insight you generate can be turned directly into an action, and this can be shared with scientists, decision makers, and the public, all within one single integrated system. For this project, we teamed up with the Department of Fisheries and Oceans Canada, who shared with us drone and aerial imagery across the Arctic seas. I will show you a few examples in Hudson Bay and the Canadian Arctic archipelago. Let's start in and zoom into Churchill along Hudson Bay. This is a drone imagery. By looking to samples of this imagery, you can see the beluga whales gliding, distinct white shape, gliding through the dark Arctic water. Sometimes it's fully visible, sometimes it's partially visible. Now let's move to the north and go to the Canadian Arctic archipelago. And there it's getting a little bit more challenging. The aerial photos showing some sea ice presence here, and the weather conditions also getting a little bit tricky to find whales or detecting them in a consistent way. So traditionally, counting whales requires a group of observers going to the field using low-flying aircraft and collecting thousands of imageries and then go back from the field and start counting these whales manually. As you could imagine, this is really a slow and a tedious and labor-intensive job. But here's the exciting part. With the help of AI, we can accelerate this workflow from months or weeks to just hours or even minutes. Let's see how can we do this in ArcGIS. So before we training our model, we need to create our training samples. So we will go to the label object for deep learning tool. And I already here have a bunch of images showing the various conditions in the Arctic seas. You can create a polygon around the whale. Change the name on the color and click OK. I can do this for a couple of images, and I can go actually using the AI assisted label here to help me to create these labels instead of doing this manually. So I can zoom in to this image here, and just by clicking on the image, I can really create the label, as you see here. And I can do this for a couple of images, or for all the whales exist in my image. Okay, so once I'm actually satisfied with my training samples, I can save them. And you should take your time here, because high quality training samples will really impact the accuracy and the model performance at the end of the day. After that, will come the next stage. We're going to use 3 critical tools in ArcGIS. The first one is export training data for deep learning. This is basically, we'll take your training samples and split this large image into smaller tiles with its labeled features. We make it ready for your training the models, and it's basically telling the training model how the beluga whales look like in the different imageries that you have. The second tool is training deep learning model. And here you can have access to different model types, different backbones. And in our project, we used actually SAM LoRa, a lightweight version of meta-segment anything model, one of the foundation models we have on the Living Atlas. Finally, we can actually, once we have our model and satisfy with the model training, we can classify pixels using deep learning tool to start doing inferencing on a new imageries and extract whales with its confidence score. Better yet, we can automate the entire process using a model builder. And we can actually, this is really ideal for large scale data sets and real-time monitoring. This way, when you have a new imagery or new data, can be integrated into this living, evolving monitoring system for the beluga whales in the Arctic. Here is examples of how the results look like. It's nice to see how the model detects beluga whales, even when they are only partially visible or the sea ice is present in the imagery. And even more interesting, the model accuracy is actually higher than what's typically reported in the literature, showing just how powerful the approach in ArcGIS can be good for real-world monitoring in the Arctic. Here is a dashboard. Once you have counting the whales, you can show this, mapping its distribution, zooming in, looking at the detection confidence and across regions and how it's varying per image source or sea ice condition. We can also bring different weather and climate data from the Living Atlas, like sea surface temperature or sea ice condition, and we start to see how this is changing over time, especially if you are interested in monitoring the habitat dynamics and try to track this due to climate change or environmental challenges. So today I showed you how ArcGIS and GUI can help us monitor marine life from above faster, smarter, and at scale. Detecting beluga is just a beginning. Could you imagine applying the same workflow to detect other species, habitat, or monitor environmental challenges here in Canada and around the world? Thank you so much for your attention. We cannot wait to see how you will use and create AI in GIS. Thank you.